Assalamualaikum warahmatullahi wabarakatuh. Can you guys hear me? We are still waiting for the rest of the class to enter. Now we've got 6 viewers. Okay, that's good to hear. So hopefully that you can hear my voice. Yeah, that's good if you could actually declare who you are, so that I would know who attends the attendance. So you can just mention in the comment section whether you can hear me clearly or not. We just wait a few more minutes. We've got 10, so inshallah if we reach the number 15, we could start. Ikmal is here. Hope you are feeling well today. It's good to hear everyone is here. We've got 11. Okay. We're on 13. So we're not sure who is present and who is not. Is the class rep here? In case you guys are wondering why am I looking upwards, I'm looking at the other screen. So that's why you see most of the time my eyes will be looking upwards. So hopefully you guys are doing well. So it's the evening, a long day, and seharian daripada pagi kan, back to back. Right, Lukman is here. So Lukman, I'll be making you as an administrator. So in case there are any other people, any of your other colleagues would like to join in the group, then probably you could help me to approve their request. For example, Arif Haziq asked to join ALFT Physics at KMS. So probably I'll just approve him as the last person that I'll be approving today. Alright, so Lukman, you can take over in terms of membership, inshallah. Okay, still got one more person to make it 15. At least by that time, we'll be more contented to start. Alright, we're on 15. Alhamdulillah, inshallah. Arif Haziq is here. Welcome, welcome. Alright, we're 5 minutes in. Inshallah, we'll begin our session with Kitab Al-Fatiha. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين آمين. Alright, boys and girls of group 1.1, we will be discussing on the tutorial question review of chapter 9, which is Superposition, which is the second part. Alright, so welcome to Facebook Live. This is actually my second video on the same topic. You can actually check out the review that I did with the previous group, which is also made available in this same group. I was thinking of just merging both of you guys into one group so that it will be easier for me, and inshallah it will be beneficial for you guys to interact, and if there are any questions from one group to the other, so both of you guys from each group would benefit from it. Apart from that, in terms of technicality, it will be much easier, and also to give you some sort of flexibility whether you would like to attend the session in your group or the other. Depends on your free time. Well, because you guys are having back-to-back sessions, isn't it? So hopefully everything goes well for you guys, and don't stress out, especially in this third phase of PKP. So inshallah. So for the second session, I will not go in detail, because if anything is unclear, you can always refer to the previous tutorial video. But if you have any questions, do not hesitate. You can either drop down a comment straight away in Facebook, or you can communicate with me using Telegram. Is also okay, no problem. So we'll be trying out this Facebook Live, and if it is okay, then we will be proceeding with it for the remaining weeks to come, inshallah. Okay, so everybody is clear? You guys can hear me? If you can, then drop me a like, inshallah. Okay, so moving on. So superposition is more on dealing with the applications in the characteristics of waves. We've got mainly on the interference as well as the diffraction. All right, so moving to the tutorial questions, we've got a coherent light of wavelength 590 Newton meters here. So anyone can tell me, when the wavelength is roughly around 519 nanometers, so what type of light are we looking at the moment? So drop down your answer in the comment section, inshallah. So this wavelength is incident normally on a double slit, as shown in figure 6.1. So this is a double slit, as you can recall. For the diffraction, here there are three main cases. One is a single slit, the other one is a double slit, and the third one is actually loads of slits lah, tapi kita tak panggil lah benda tu kan, kita just panggil diffraction grating. Okay, so the separation of the slits A and B is 1.4 millimeters. So if you can recall Huygens principle, because it says each particle at the wavefront can act as an independent source. So when moving through the double slit, points A and point B will become two sources, and since the light is coherent, so these will be the two sources in order for us to observe interference. Okay, we've got a couple of answers. Tryouts: red light, green, yellow. We see how it goes. Okay, yes, it is a visible light, Iman. It is a visible light, but I would like to know what color is it. You got 7 options to choose from, inshallah. Okay. So the first question is determine the separation of bright fringes on the screen near to point P. So when we play around with the concept of diffraction, we've got a few measurements to consider. We've got the width of the slits, which is here. Usually we term this as D, small letter D. And then we've got the distance between the slit as well as the screen. This one we term it as capital D. And then we've got the screen, where on the screen we will see the pattern of fringes. Maknanya dia ada yang selang-sili macam zebra crossing tu lah. Okay, so you just have to know the formula, and this formula is not given in your question paper. You just have to know it by heart. So y is equals to lambda d over d. All right, there you get one mark straight away by quoting that particular formula. This is a 3 marks question, and then substituting the values with the correct, substituting the variables with the correct values and converting it so that it would have the same magnitudes or the same units. So nano and milli, watch out, and then you have to convert it again to millimeters because the question is asking in millimeters. Okay, so plug in the values, you get 1.1 millimeters. All right. Quite straightforward, isn't it? All right, moving on for part 2. The variation with time of the displacement x of the light wave arriving at point P on the screen from slit A and from slit B is shown in figure 6.2a and 6.2b respectively. So this is the variation with time at point P of the wave from slit A. The bottom one is from slit B. As you can see here, both have 0 phase difference, isn't it? Sebab apa? Sebab dia dekat center. Okay, so kat sini dia ada beza antara path difference and phase difference. So phase difference, you measure it in radians or in degrees, but path difference is the amount of path that is being traveled by 2 different sources. So that one you measure in terms of distance travel, which is in meters. So kat sini dia just kata dia nak phase difference dulu. Tapi dia nak phase difference dekat mana? Dekat point P ke? No, that is not the question. If you look carefully, state the phase difference between waves forming the dark fringe on the screen that is next to point P. So the waves that is displayed here are waves located at point P, which is the bright waves, the bright fringes. But next to the bright fringe is a dark fringe. So how do you visualize this? So this is an example of the what is happening in the middle of the screen. So who answered yellow is correct. Because the answer is yellow, approximately yellow. 590 nanometers is approximately a yellow visible light. So siapa yang jawab yellow tu, you can claim your prize from your class representative, insyaAllah. Okay, sorry Luqman. Right, the order is n equals to 0, path difference is 0 degrees. So in between the bright fringe, you've got a dark fringe. So where does this bright and dark fringe originate from? Okay, so when we have interference between 2 waves, so we would automatically know that for interference, we use the principle of superposition. When a crest meets or overlaps a crest, ataupun a trough meets and overlap a trough, that will create constructive interference. Okay, lollipop magnum, if you answer correctly, boleh claim, nanti dia hantar. And then if you have a dark fringe is destructive interference. Maksud dia apa? Destructive interference ni, crest meets with trough kat situ. Okay, So macam mana, the question is asking how did the dark fringes form? So basically it's due to the phase difference. What is the amount of phase difference for us to achieve a crest meeting a trough? So kalau kat sini yang ditunjuk kat sini is at point P, where point P is a constructive interference, so the phase difference is 0 degrees kat sini. Tapi kalau kita tengok dia punya kalau kita nakkan destructive interference, so if looking at the top fringe, so wave from point B will have to travel more, so dia akan travel pi radians more. Okay, is it pi half or pi? Sebab kalau a full circle is 2 pi, so kalau pi half is actually a quarter. Yang tu tak akan bagi complete destructive interference, dia masih lagi ada. So you need a pi ataupun kita panggil 180 degrees phase difference in order to achieve the particular dark fringe. So kalau pi half ni dia lebih pada macam spectrum going from dark to bright, somewhere in between. Alright, and then determine the ratio. Okay, so what is the ratio? We want the ratio of intensity of light at a bright fringe, and then we've got intensity of light at a dark fringe. So kita boleh tengok kat sini the amplitude. Okay, these are two coherent waves, but they have different amplitudes. So the amplitude for the first one originating from point A is 2.0 units, and the amplitude originating from point B is 1.4 units. So when it is asking for the ratio of intensity between two waves, we will automatically remember the relations that we previously have already discussed. Is either the relation of intensity is directly proportional to amplitude squared, or it is inversely proportional to the radius squared. So kat sini, sebab kita tak tahu radius dia macam mana apa semua, kita tahu dia punya amplitude, so we use that as our relation, which is apa? Kat situ. So the amplitude at a constructive interference, that means crest meets crest, is 3.4 units, maximum at a bright fringe. At a destructive interference, crest meets trough, so it's 2 minus 1.4 ataupun 1.4 minus 2 pun boleh sama, so it's 0.6 unit. And since intensity is proportional to A squared, so yang tu ada error sikit dekat dia punya slide tu, is actually equals to A squared, therefore the ratio of bright to dark is 3.4 squared over divided by 0.6 squared, it is equals to 32. Alright, so if you have any questions, drop a comment. Inshallah, we will be proceeding with the next question. Alright, apparatus used to produce interference fringes is shown in figure 6.1. The apparatus is not drawn to scale, fair enough. Laser light is incident on two slits. The laser provides light of a single wavelength. The light from the two slits produce a fringe pattern on the screen. A bright fringe is produced at C, which is the center, and the next bright fringe is at B. A dark fringe is produced at P, in between B and C. Okay. Number one, explain why one laser and two slits are used instead of two lasers to produce a visible fringe pattern on the screen. Okay. So how do you answer this? So basically what we want is actually a coherent source. Two coherent sources that interfere between each other. Okay, my question to you, if you can answer. Okay, Shazwina asked, can I answer 289 divided by 9 for the ratio? Well, I would ask you again, are you expecting the examiner to complete the division for you? So elok-eloknya you just bagi nombor bulat lah kan, supaya taklah dia kena tekan calculator, kita nak check sama ada is it the same value of 32 roughly equals to 32. Okay, thank you for the question. So back to my question, can we have non-coherent sources for interference? Yes or no? Sepatutnya boleh buat polling ni sebenarnya. Create a poll. Tapi tak apalah. Maybe we save for another time. My question was, can we have two non-coherent sources for interference? No, 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 no. Okay. So technically, in this scope of study, we want two coherent sources. So why? Why do we want two coherent sources? Sebab dia idea kat sini ialah dia kata to produce a visible fringe pattern on the screen. So kalau kita ada two coherent sources yang sama, so laser dia lalu two slits, so kita akan ada the same lasers lah kan, basically kan, and then they interfere. Yeah. Tapi if the two sources are not coherent, can interference occur? Yes, it can. Sebab interference can happen to any particular type of waves as long as they overlap kat sini. Cumanya apakah implikasi if the two waves, the two source waves are not coherent between each other? So the fringe pattern on the screen would not be visible. Itu saja beza dia. So in this, interference will occur, but it is a matter of the visibility of the pattern that we can observe on the screen. Itu saja. Kalau kita tak ada coherent waves, dia tak akan nampak cantik seperti mana yang kita adalah dalam scope of study here. Alright? So let's just clear that concept up. Tapi basically for our scope of study, we want coherent waves. So why one laser and two slits are used? Because kita nak coherent waves lah. To produce coherent sources, i.e. sources that, what does it mean by coherent? So yang ni you kena revise balik daripada chapter 8 waves part 1, where the definition of a coherent source, dia kata sources that have constant phase difference. That means they are coherent in terms of, it does not mean it does not have any phase difference. It has, but it is constant. Maknanya dia tak berubah-ubah kat situ. Alright. Part number 2, state the phase difference between the waves that meet at point B. So what is point B? Point B is a bright fringe. So kalau bright fringe, dia ialah constructive interference, CI. So kalau constructive interference, dia antara crest dengan crest ataupun trough dengan trough. So dia tak boleh jadi 180, sebab kalau 180 dia destructive kan. So it can be multiple values of 2 pi. So it can be, kalau ikutkan, it is exactly 2 pi lah, because this is the first bright fringe after the center point kan. So the order is n equals to 1. So the answer should be 360 degrees or 2 pi radius. But if you answer it as n 2 pi, where n can be 1, 2, 3, 4 and so on, it is also acceptable. What about the phase difference that meet at point P? Is a dark fringe, so destructive interference 180, similar to the previous question. Alright. Now, state the principle of superposition. This is quite straightforward. When two or more, so dia tak semestinya dua kan, dia boleh lebih banyak pun tak ada masalah. It depends. Okay. When two or more waves meet and overlap, so that is the criteria for principle of superposition. Dia tak boleh ada social distancing. Kalau ada social atau physical distance, dia tak boleh nak overlap. So dia tak ada superposition kat situ. Okay, so right now we practice social distancing in order to break the chain. So the resultant displacement is a sum of displacements of each wave at that particular point. the position of the particle. You get 2 marks kat sini. So this is the formal definition based on A-level physics. Use the principle of superposition to explain the dark fringe at P, which is the explanation of crest meets trough. The dark fringe represents destructive interference, so you just have to mention the destructive interference when a crest interfere with a trough. So kita basekan this concept of a dark fringe using the principle of superposition by defining it is a destructive interference kat situ. So they cancel each other out. In figure 6.1, okay, this is where the calculations come in. We want to calculate the wavelength of the light provided by the laser. So this is a double slit situation. We use the same formula that we used in the previous question, y equals to lambda d over d. So we want to find out what is the value of lambda. So we rearrange. We are given y. So kat sini you have to be careful. What is the value of y? Okay, Iqbal is asking, do we have to memorize the definitions exactly? That is the trick in order to master master physics kan. Nak dapat A star ataupun A kan. If you read the schematic answers, the ones that are underlined are the keywords, and if you have to play around with your own understanding is good. It's a freedom of speech, you can do that, but as long as kalau orang kata kita gini kan suka menggoreng kan, kalau goreng tu takut hangit hangus, takut tak jadi pula. Itu je pesanan dari penaja. So it's good if you can make sense of the definitions that are already given and use that definition to be your understanding. Okay, sebab takut ialah language kan, it's a matter of language, takut kita tersalah maksud. Macam apa, ada orang pernah buat discussion, you guys know about Boston Tea Party kan, the revolution, Boston Tea Party. Kalau terjemahan dia kepada bahasa Melayu, jamuan teh Boston. Which is quite odd lah, sebab party tu is not actually referring to the jamuan, tapi party tu ialah parti politik tu. So it's okay. So itulah language barrier. In figure 6, okay, back to the question. The distance CP is 2.3 millimeters and the distance between the slits is 0.25 millimeters. So kalau katakan the distance between the slits is 0.25 millimeters, which is actually referring to this part lah. This is the value of 0.25 millimeters. What about the distance D? The distance D is actually the distance from the two slits to the screen, which is 1.8 meters. So this the long distance. Cuma dia kata the distance CP. So C and P is actually bright and dark fringe. But is that the definition? Is that the formal definition of Y here? Where Y is actually the distance between two bright fringes ataupun two maximas. So you actually have to multiply the value of 2.3 by 2. Sebab apa? Sebab 2.3 is only C to P. But what we want is actually C to B kat situ. Okay. So the value lambda is actually almost equal to 639 nanometers kat situ. Yes. So you have to times 2. Okay. Alright. So 639 nanometers. So what color is the laser? The laser is red. Dia memang suka red je lah. Alright. We are in 30 minutes of our session. Are you guys doing okay? Masih lagi boleh go proceed? Nak rehat? Boleh sambil-sambil minum-minum? I can't see you guys. So you have complete freedom to do whatever you want. So ni downside lah untuk FB Live kan. Tapi I would know if you do not respond. If I call upon your name and you do not respond, maknanya tak ada lah tu kan. So tak apa, nanti kita akan tengok proceed nanti macam mana. Sebab kalau dalam previous group tu dia ada comment, kalau buat macam ni dia tak boleh nak interact live. Maksudnya dia tak boleh nak tanya soalan tu. Dia boleh just type je kan. So kalau kadang-kadang type ni jadi slow. Tapi tak apa. Okay. Moving on to the third and last question for this tutorial. A laser produces a narrow beam of coherent light wavelength 632 nanometers. Red light juga. The beam is incident normally. So incident normally maknanya dia perpendicular lah kan. The beam kat sini, dia maknanya dia exactly perpendicular to the diffraction grating. This is important to ensure that you have a clear visible pattern on the screen. Spots of light are observed on a screen placed parallel to the grating. Okay. The distance between the grating and the screen is 165 centimeters. The brightest spot, of course, is P. The spots formed closest to P and on side of P are X and Y. Okay. X and Y are separated by a distance of 76 centimeters. Calculate the number of lines per meter on the grating. So kita tengok dulu soalan daripada netizen. Dia kata, do we need to memorize wavelengths of colors as well? Well, it's either you memorize the wavelengths, the range of the wavelengths, or the frequencies. Because visible light, we've got 7 lights. So at least you have a feel of the range values. Dia ada dia punya mnemonics kan? Apa istilah dia? Yang MJ kan? I don't know what you guys do untuk nak memorize kan? But in my time, kita orang guna Michael Jackson kena halau balik India Utara. So mungkin zaman dah berubah. So those value, those colors have different wavelengths. So it is part of a visible light. Visible light ni dalam spectrum electromagnetic waves. So we have to know that kat situ. Okay. So kenalah somehow. Just bear with it for the next 1 year, inshallah. So calculate the number of lines per meter on the grating. So what is this question is actually asking you what? What is it actually asking? It is asking how many openings or how many slits do you have in a diffraction grating kat sini per meter. Okay, so kita ada single slit, kita ada double slit. So sekarang dia nak tahu berapa slit dalam diffraction grating kat sini. Okay, so how do you do this? There is a concept where you have the angles theta, which is you can define theta as P to X. So if you have a laser light here, so X would be a bright fringe kat sini lah, apart from P kan. Tapi if you have a white light kat sini, so the diffraction grating will diffract the light and it will produce the colors of the rainbow kat situ. Okay. Tapi kat sini dia monochromatic light kan, so dia akan just bagi sama je lah. Okay, so you actually can deduce by trigonometry. Theta is equals to arctangent, which is the opposite against the adjacent. 76 divided by 2 divided by 165. So theta is equals to 13 degrees. So what do you use the theta for? You plug it into this formula, which is actually designated for a diffraction grating. It's different from the previous usage of formula for the double slit. Tapi sebenarnya dia lebih kurang sama je lah if you actually play around with the derivations. So d sin theta is equals to n lambda. So what you want to find is actually the value of d. Tapi d is the distance between the diffraction gratings. Okay, bear with me. So n equals to 1, which is the first order. Lambda is given 632 nano, and then you got sine 13 degrees. So the grating spacing is 2.81 micrometers. Okay, is this the final answer? No. So that means the spacing between two lines or two strips is roughly around 2.81 micrometers. It's very small. So dia nak tahu kalau dalam 1 meter ada berapa banyak grating tu, ada berapa banyak spacing tu. So what do? You take the inverse. Yes. So the number of lines per meter on grating is equals to 1 over d. So it is actually equals to 3.6 times 10 to the power of 5 lines per meter. So this is the amount of slits ataupun the amount of spacing yang ada dekat sini. Alright. So dia bukannya nak tahu grating spacing tu berapa, dia nak tahu ada berapa banyak line grating tu lah per meter kat situ. So the value is how many number of lines per meter you have. Right, proceeding to part number C, the grating in B is now rotated 90 degrees. It's either clockwise atau anti-clockwise, dia tak cakap lah kan. Tapi sebab dia monochromatic light, so this lah. Rotated about an axis parallel to the incident laser beam as shown in figure 4.2. So state what effect, if any, this rotation will have on the positions of the spots P, X and Y. So assuming that kalau ikutkan before rotation dia menegak lah kan, unless it depends on kita contohnya kita ambil ni, we assume this is the side view, tapi kalau ikutkan sepatutnya dia macam this is the top view kan, but it does not say kat situ, sebab yang ni pun either menegak ke melintang kan. So okay, tapi apa yang jadi ialah the middle part which is X, the middle spot which is P will remain unchanged. The brighter spot at the center remains the same. Sebab if you shift it in the mid, dia macam dia rotate 90 degree saja kan. So dia kat tengah-tengah. Unless you pusing kat tepi, mungkin yang tu dia akan change sikit lah. Tapi yang ni dia memang betul-betul rotate saja. Just 1 degree of motion. And then the XPY are rotated 90 degrees. So daripada tegak, dia melintang. Of course, this one is not to scale lah kan. Sebab dia kata not to scale kan. So everything is not to scale. Even my drawing is also is not to scale lah. Lagi-lagi drawing guna PowerPoint kan. The best method of drawing if you do research until PhD pun paling senang if you kalau nak buat CAD engineering apa at the end, last to draw online guna PowerPoint in the end. Okay. So in another experiment using the apparatus in B, a student notices that the distances XP and PY as shown in figure 4.1 are not equal. So dia macam distort sikit lah kan. So apakah punca benda ni berlaku? So there are probably several factors. So what is suggested here is either the screen is not exactly parallel to the refreshing grating, maknanya dia tak betul-betul tegak lah kan. So mungkin the screen slanted ke, ataupun ada budak main terpijak ke, or the grating is not exactly normal to the incident laser light, but it is already stated here the beam is incident normally. So tapi mungkin dia tersilap kira ke apa, there's an error in dia punya experiment and whatnot. Okay, so with that it concludes the 3 questions of our tutorial session. Any questions? Lagu kat YouTube, boleh kita buat lagu red, orange, yellow, green, blue, indigo, violet. Okay, so let me just give you an overview of what we have been doing for the past 2-3 weeks, especially during PKP lah kan. So a good question by Iman, is diffraction grating a polarized filter? Probably you can perceive it that way. So if you have an EM wave or electric field, so what is being filtered is actually only the one that is in parallel lah kan, to the direction of the diffraction grating. Cuma kalau tengok dalam kita punya example tadi tu, kenapa dia boleh juga rotate 90 degrees? Because of Huygens principle tu, it acts as a source, a point source which is travelling 360 degrees. So dia masih lagi boleh go through everything in any direction. Okay, good question. Thank you very much. So let's do an overview of the entire materials that we already done. So we did waves part 1 and part 2. That was long before you even had already answered the quiz, the online quiz. And then we got superposition part 1, and you have just only recently finished superposition part 2. So what are actually the main the crux of each part of the chapter? You got here waves part 1, you were introduced ataupun you were reminded again, sebab dah belajar dulu waktu SPM kan, progressive waves. So kalau ikutkan progressive, dia punya pair is stationary waves, so dia macam jauh sikit. So you have to recall progressive travelling waves, stationary is the superposition between the incident and the reflective waves, and then you get a stationary waves kat situ. So we've got two types of waves lah, basically kan. We've got progressive travelling and you got stationary ataupun standing waves. So for these two, dia boleh either jadi transverse ataupun longitudinal. So that's why I coloured progressive with blue colour, stationary with blue, just to show that these are the two main types of waves. But at the same time, dia boleh jadi transverse, dia boleh jadi longitudinal juga. Okay, and then you can recall, we were reminded again by the wave equation, V equals to F lambda. V is the speed of wave, F frequency, lambda is the wavelength. And if you notice, this wave equation has been used throughout, even in superposition juga, kan? And then kita masuk Doppler effect, an application of progressive waves somehow, yang dia ada bunyi tu kan, kat situ. And then we've got EM waves. So I highlighted this in red just for you to know that you have to memorize, and you have the values, it's either the frequency or the wavelength, because the speed of light is still 3 times 10 to the power of 8 meters per second. But including the visible light spectrum. Okay, and then the principle of superposition is introduced again because it is an introduction to stationary waves, and it always remembers stationary waves. We've got three cases: the string, closed pipe, and open pipe. What are the main differences between string, closed pipe, and open pipe? Is actually the location of the nodes. You've got both ends as nodes for a string. For a closed pipe, either end is a node, the other one is the antinode. Then you've got the open pipe, both are antinodes, right? And then for part 2, you are introduced by Huygens principle. That is the basic fundamental concept in order for us to observe interference caused by it's either a single slit ataupun double slit. Double slit lah yang ada interference tu kan. Kalau single slit tak ada interference yang kita boleh nampak kan. So kat situ lah the concept of diffraction. Interference we got two, it's like constructive and destructive. Pendetailan kepada superposition lah. And then diffraction we got single slit, double slit, and diffraction grating that you have already done with the exercises. Alright. Any questions with the overview of our topic? So suka untuk saya nak cerita, for tomorrow you will be having your test, where that test will assess your understanding on superposition part 1, which is more on the stationary waves lah kan, kat situ. And then on Friday is going to be a quiz, test lah, quiz lah, assessment lah on interference and diffraction. So untuk esok ni kena recall balik pasal ni lah, concept of node, antinodes and whatnot. And then Friday, apa yang kita buat hari ni will be assessed on Friday insyaAllah. Okay. Any questions? Tak ada, semua dah penat lah kan. Petang. So we are 17 people with us live. Ada seorang lah sepatutnya yang tak ada kan. So because seorang ke dua orang lah kan. Because it should be 19 altogether, including me, we've got 20. So macam mana? Kelas rap boleh cari tak siapa yang ada, siapa yang tak ada. Make sure you guys at least comment on the comment section at least once, because I'll be going through. Nak tengok siapa yang comment, siapa yang tak comment. Okay? Are you guys okay setakat ni? Yes, you will be getting this slide in the Telegram insyaAllah. Sorry for the late reply, sebab I'm using a third-party software in order to have this screen sharing, as well as you can see this window for you to observe my hands as well as my facial expression. Jadi kalau benda ni tak bagus, mungkin share screen sajalah kan. Tapi nanti dia macam, apa beza dengan you all tengok YouTube kan? Tapi tak apa, kita tengok macam mana. Alright. Okay. So it's okay kalau you ada question, you can always ask dalam Telegram juga, ataupun PM ke, interaction with the dalam feedback notes pun ada juga kat situ for some of you. So I'll be responding them individually insyaAllah. So just as a bonus slide for you guys, take home message untuk hari Rabu ni lah kan. The first day of phase 3 of PKP. Okay, we've got a question. What is polarization? Polarization in physics lah, specifically in waves lah. So if the wave is travelling at one angle ataupun multiple angles lah kan, so dia macam kalau kita bayangkan an electromagnetic wave, dia ada both elements of the wave. So if it goes through a polarization punya strip, apa yang akan berlaku ialah dia akan polarizekan only the waves acting upon one direction saja. So to polarize lah kan, in terms of waves lah. So dia just nak eliminate all the unwanted characteristics of the original wave kat situ. So that is polarization dalam bahasa saya sendiri. Tapi formal definition kita boleh bagi lagi nanti lepas ni macam mana. Semua kalau dalam, if you notice, kalau kita punya subject matter ni dia tak sentuh sangat pasal polarization kan. Dia lebih pada diffraction, interference kat situ, principle of superposition kat situ. Tapi moving forward kita tengoklah nanti macam mana kan, because after this the chapter 10 is going to be on electric fields. So that's when mungkin kita ada mechanical and electromagnetic electric fields kan. So probably we'll see, but as of now tak ada lagi kan. So kalau tak ada, kita tak minta lah kan. Nanti jadi lebih pening kepala. Alright, thank you for the question. We still got time insyaAllah for a bonus slide. Okay, first I would like to ask all of us to recall the relation between wave intensity being inversely proportional to the radius squared. We actually did a proof on this kan, last Friday in one of the tutorial questions, where we know that intensity is equals to power over area, where area is the surface area of a sphere. It's not a circle. So kalau circle pi r squared saja kan, tapi kalau spherical dia 4 pi r squared. So kat situ, if we assume the other values, the other parameters are constants, so we can actually have a relation between I and r squared, where I is inversely proportional to IR squared. Okay, sorry, I is inversely proportional to r squared. So now what we can understand here from this relation is, the further the position from the source, is wave intensity gets weaker. Betul tak? Maknanya kalau R meningkat, kalau R yang ni the value increases, that means gets further, I will go down. Contoh kan. This is adhered ataupun dia ikutlah the inverse square law. Okay. So assuming that this is a point source of our wave, so the further you get, for example, this is R. So the intensity kat sini will have a certain value. But if we proceed further from the source, the intensity will reduce by itself because of the increase in surface area. Tapi the effect of the intensity at one particular point at that distance would reduce. Okay, so this is physics. Ya, cerita kat kita kan, betul lah kan, semakin kalau kita cakap dengan seorang pun, let's say for example, if I'm close enough in the microphone, you can hear me. loud enough, but if I go back, dia akan jadi lebih jauh lah kan. Sorry kalau terkejut. Tapi nak ceritanya, the concept of distance lah kan. The further you get, that means the less intensity you will have. Okay. Review this verse in the Quran. Allah subhanahu wa ta'ala says, وَقَالَ الرَّسُولُ صلى الله عليه وسلم يَا رَبِّ إِنَّ قَوْمِي اتَّخَذُوا هَذَا الْقُرْآنَ مَهْجُورًا. So what does it mean? This one you can actually see in chapter number 25, verse number 30 from Surah Al-Furqan, the chapter of the Furqan, which is the Al-Quran. Allah SWT says, and Rasulullah SAW said, O Rabb, Ya Rabb, O my Lord, verily my people have taken this Al-Quran as something that is being abandoned and forsaken. Maknanya dia kata, Inna qawmi, my people, ittakhudhu, have taken hadal Quran, this Quran, as something that is abandoned or forsaken, mahjura. So to understand the word abandoned and forsaken here, we look at the verse. Here it says it's mahjura. So what is mahjura? In Arabic language, is actually a very beautiful language. You can see here the letters of ha, ja, jim and ra is hajar, hijrah. Hijrah kan, hijrah tu apa, perpindahan Nabi daripada satu tempat yang lain. Hijrah is actually a distance. So when you term mahjura, that means we are taking the Quran to become very far. So what does it have to do with intensity? So the concept of intensity, it says here, if you are further from the source, that means the less impact it will have on you. So this is the reality that we are living in right now, unfortunately. Kalau kita tengok contohnya, we have the Quran, but we are running away from the Quran. We do not want to get closer. And what happens when we want to run away from the Quran? The effect of the Quran, the intensity of the Quran towards our hearts would reduce. The further we get, the less intensity of the Quran. And what will happen? We will be at a loss. Sebab kita takkan dapat the benefits, the perks of understanding the Quran at its true value. And on last Friday we did the tutorial session. We recalled how our hearts, it vibrates when it says innamal mu'minuna idza dzukirallah wajilat qulubuhum wa zadatuhum imana. When the believers are those who, when they remember Allah subhanahu wa ta'ala, the hearts vibrate. And this vibration, if it reaches the natural frequency, will achieve harmony. And that's where the calmness or mutma'innah is achieved. And when we have that type of calmness, nothing will stop us. We'll always be confident, everything will be all superb, and nothing will go wrong in our life. But the reality right now, what happens? Imagine this. Instead of trying to synchronize our hearts with the Quran to achieve harmony, we abandon it. The fact is, the further we are from the Quran, the less effect it will have on our hearts. This is a situation that we are very worrying. This is a very worrying situation. Alhamdulillah, today we are living in the time of Sha'ban. Just a few more days before Ramadan. Shahrul Ramadan, Shahrul Quran, the month of Quran. It's actually a good opportunity for us to actually go back to the Quran and actually understanding the verses of the Quran. If I ask you, if I were to say that for 1 hour, that babbling sound, what would you call me? Am I a sane person or a crazy person? Of course, you will be a crazy person, because what is he talking about? Babbling all the way, blah, 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 not understanding even a single word of what he is saying. And that is the reality of us right now, today. We recite the Quran, for example, the Fatiha, or the Surah Al-Ikhlas, Surah Al-Nas, Surah Al-Falaq. But do we actually understand? Or are we just babbling Arabic words without actually understanding at least the literal meaning of it? And not to say the actual tafsir or the interpretation behind each of the verses of the Quran. And when we know the Quran is actually the words of Allah subhanahu wa ta'ala, the wisdom of Allah subhanahu wa ta'ala bestowed upon us as humans, for us to actually know what to do in our life. So what we have to do now is actually to go back to the Quran. Refer back to the main reference. It is not Wikipedia, it is not Quora, it is not your textbook. It is the textbook in life. But my question for you, how do we do this? How do we actually go back to the Quran? Is it just a matter of, because we are reaching Ramadan, and this Ramadan is kind of weird, first time in our life, Ramadan in our homes, where siapa yang jadi imam? Takkan your parents, your ayah jadi imam kan? Especially the boys lah kan? Boys, macam Arif contohnya, mestilah kena jadi imam sekarang kan? Instead of just asking your father to become the imam kan? So, is it just a matter of recitation without any understanding? Dia akan jadi sedih lah kat situ kan? Where in fact the Quran, if you be close to it, close in terms of proximity, that means you always read it. And the most intimate position when you can have with the Quran is actually bila you memorize the Quran, it is in your heart. So itu, just imagine the Quran is within your heart. So imagine that intensity you have in the Quran, subhanallah. And even Aisha radiallahu anha, when the Sahabas asked of Aisha radiallahu anha, what is the character of Rasul sallallahu alaihi wasallam? He says he is actually a khuluqul Quran, and he's a walking Quran. His akhlaq is al-Quran. He is the embodiment of the Quran. That's when you have that proximity. But my question is, kita tahu benda ni, but how? What is the process? That is my question to you. This is actually the third question lah kan. First question is, when you have crest and trough, how do you ensure that your actions are within the scope of the Sunnah of Nabi sallallahu alaihi wasallam? Second question is, how do you want to ensure that the vibrations of the hearts and the Quran is actually achieving the natural frequency? And this one, we know we have to go close to the Quran. But how? Adakah bermaksud kita ambil Quran tu letak kat dada, so tak macam tu saja? No. How do you do it? Is it just blind memorization? That is my question to you, for you to ponder, inshallah. Wallahu alam bisawab. Inshallah, if Allah wills it, we can have this type of discussions later on. Lebih baik lagi. We pray to Allah subhanahu wa ta'ala, Allah subhanahu wa ta'ala bestow upon us His hikmah in order to understand His knowledge in physics in general. But what is more important is actually knowing what to do in our life. That is the most important thing that we should not forget about. Wallahu alam. So I guess that's it for today. We're a few more seconds to reach the 60 minutes mark of 1 hour. I hope you guys have had a fruitful discussion ataupun exchange ataupun presentation on our tutorial questions. If you have any questions, you can always come back and ask me. أقول قولي هذا وأستغفر الله لي ولكم. السلام عليكم ورحمة الله وبركاته. We adjourn with tasbih Quran Surah Al-As. Bismillahirrahmanirrahim. سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك. بسم الله الرحمن الرحيم. والعصر إن الإنسان في خسر إلا الذين آمنوا وعملوا الصالحات وتواصوا بالحق وتواصوا بالصبر والحمد لله رب العالمين. Bye bye.